with the determinant which is 7. So if this is not given class, you have to solve the determinant of the matrix here. Okay? So evaluate 2 and then a cube. So since this is a 3 by 3 matrix, you raise your 2 to cube and then determinant of a cube. So 2 cube times 7 cube, you have here letter C, 2744. Next, number 4, you have this. In the vector space R3, let M be a real number and M is equivalent to this vectors with these vectors. 4 vectors are elements of your M. Be a vector set. Find M, the small m here, such that the capital M is a spanning set of R3. Okay, this is number 4. Hmm. So there are many values for M here that such that the capital M is a spanning set of R3. So we have a result previously that if you can see it there in the vectors slide, if the determinant is, wait, where is that? Okay, if the determinant is not equal to 0, then it will span your R3. Okay, and that's it. We have to make the determinant not equal to 0. So we solve it. Before we do that, since this is four four vectors are here. So what to do? We eliminate one. We have here v4. V4, the vector 4 is just v1 plus v2. So therefore, v4 is dependent on v1 and v2. Okay, so as you can see here, if you add it, this is 1 plus 2, it's 3, -4 plus -7 is -11, and then 1 plus 2, it's 3. So it's equal to 4, v4. So we can drop v4 when checking rank. Okay, so we only use v1, v2, v3, and write them in a matrix. So first, you write the v1 in the first column, the numbers here. V2 second column, and your v3, 1, 2m will be in the third column. So here, the determinant must not be equal to 0 so that it will span the R3 there. So solving the determinant, we use the row 1 here. So first pick 1, then eliminate row 1 and column 1. You have here -7, 2, and then 2m is the remaining. Next, the second number here, we pick 2. So you have to minus it, okay, because we multiply this with -1, right? To the power of this is row 1, column 2. So 1 plus 2 means cube. So it should be -1. I'll just do the alternate plus, then minus, then plus is the next so that you are not confused anymore with the -1 there. And that's it. Delete the second column and the first row. You have a -4, 2, 1, and m, and then plus the third number here, which is 1. So delete now the third column and first row. You have the remaining numbers here. You have -4, -7, 1, 2. Now we solve the determinant of this. -7 times m, we have here 7m minus 4. Then this one is -4m minus 2. And then this one is -8 plus 7. Correct? It is -8 plus 7 because this is minus -7 here. So it becomes -1, which is there, -1. So -7m minus 4 and then -4m minus 4. Now we solve, we multiply the 1 there. This is the result. Multiplying 2, we have 8m plus 4 and then -1. Now combine all the terms with m. So we have here -7 plus 8m. Then combine the constants there. -4 plus 4, this is 0, then -1. So we have m minus 1. So your determinant of A is equal to m minus 1. And this one should not be equal to 0. So your m minus 1 should not be equal to 0. And that's it. It means that your m must not be equal to 1. Because if this is 1 here, so 1 minus 1 is equal now to 0. So that's it. Um, the answer here is letter C. So you will ask me like, sir, if m is not equal to 1, so any values for m, it will span R3. Yes. Um, it will span like the negative numbers you can choose and the numbers greater than 1, like 2 and 3. So it will span your R3. Okay, next. Number 5, in the vector space P2x, let m be a real number and m is equal to this vector set. Okay. Now, as you can see here, the vector set are written in quadratic expressions. Okay, so what to do here? Yeah, what to do here is your P2x here, class, is actually the set of quadratic polynomials. Okay, a space that contains quadratic polynomials. So all you have to do is to get the constant here. First, with the x squared, you have your negative 4, 2, and then 1. Here, for we have x squared, so that's 1. There is no x here, so 0 for the x, and then 2 for the constant. Then here, there is no x squared in the third vector. So 1 is for the 0 for the x squared here, and then 2, and then m. So to write that, you have this -4, 2, 1, 1, 0, 2, and then 0, 2m. Again, this is 0 because there is no x squared here. And this is 0 here because there is no x here. Okay? That's the coefficients of your x squared, x, and 1, or the constant. Okay, now next, if we go back, the question is asking for find m such that your m is linearly independent. Your m is linearly independent. Now, for linearly independent, um, your determinant of a there should the process is still the same with what we did. Now arrange the numbers in the first column, 102 in the second column, and then 0, 2m in the third column. Again, determinant should not be equal to 0. So we use there the first column. Okay, so we only use negative 4 and 1 there, right? So negative 4 times 0 to 2m minus 1 and then multiply 2 to 1m there. Okay, because you eliminate this row and vertex here if you pick the 1 there. So 2 to 1m. Then if you pick negative 4, you delete this and this one. You have 0, 2, 2m as the remaining in the matrix. And that's it. And now for the third one, it's 0 already, so no need for you to write it actually. So only this. Now we solve the 0 to m. We have this is 0, 0 times m minus 4. That's it. Next we have 2m minus 2. 2m minus 2. Then substitute it here and here. We substitute it there. So we have negative 4, and then this one is negative 4 minus 1. And then the answer for this is 2m minus 2. So this is positive 16, and this is minus 2m plus 2. It's equal to 18 minus 2m. Now, your determinant should not be equal to 0, and this is your determinant. So your 18 minus 2m should not be equal to 0. Transfer 2m to the other side. It becomes 18 is not equal to 2m. 18 is not equal to 2m if you transfer the 2m there. Or 2m is not equal to 18 by symmetric property. Then divide 2 there. Your m should not be equal to 9. Divide both sides here by 2. And that's it. And where is that? Letter B. M should not be equal to 9. Next, you have this number 6. And actually, class, I did everything just to get the answer. The answer in the answer key is letter A there. So I have this. When you go here, if you have here the current going here, so it will enter from in the part A here. I1 is the current here, right? So I1 will enter in the R3. So we have I1 is equal to I2 plus I3. Now, if you transfer I3 to the other side, it becomes minus. So that is why we have here I1 minus I3 is equal to I2. And then you can form these two equations also inside the circuit. Now, next, what did I do there is we have an I2 here. We substitute it here in equation number 3 so that we have I1 and I3 only. So substituting it there, we have 4i1 minus 4i3 because you have to multiply it here and then minus 5. Now combine the i3 here, we have minus 9i3. Just copy this too. Now this one we combine it with equation 2 there because our equation 2 has 1 and 3 only. Okay. Now what are we going to do is we are solving for I3. I1, right? Because the question says what is the current which flows through R1? So we compute I1 only. Um, so get the two equations. Now you can click this in your calculator. You can let I1 there be X and then I3 be Y. Then you solve, you get the X there. Your X is 70 over 19 and 70 over 19 is 3.68. Okay, next. Question number 7 through 9. We have this one. Let m be a real number such that this system has infinitely many solutions. Okay. As you remember, if you have an infinitely many solutions, says here find m for number 7. If you get the augmented matrix for this one, you have there 2 and then 3, 4, m and then 2. Okay, m is a constant here. And now we are going to solve for m. What does it mean if we have here infinitely many solutions? Our goal here is to make all the numbers here in the third row be equal to 0, right? That's our goal there. Make all these numbers here be equal to 0. And that's it. You have now infinitely many solutions. Again, if the question says has no solution, for example, so you have to make this 0, 0, 0 here, and then there's a number here. Okay, that's for the no solution. Okay, please remember that one. Okay, so get the numbers. Okay, now apply this. Um, what are we going to do is to make this 0 and 0 here, correct? The 2 and 3 here. So we have R2 minus 2R1, and then R3 is minus 3R1. This is row 1, okay? And row 2, row 3. Applying that, you will have this 1. Okay, this is the new one. 100 is are here. Now next, they didn't change the negative 1 anymore to 1, and it's fine. But actually, you can change this. You can make this 1 here. This is negative m, and then this is positive 2. Okay? What he did is they make this 0 already. The number here, the negative 2, which is, you can use this. You multiply this with negative 2 here. It becomes positive 2. Then when you add it in the row 3, it becomes now 0. And that's it. Applying that, we have 100 and this one. Now, all numbers there in the lower part are zeros except the negative m plus 3. So we have to make this 0 because that's our goal. The last row must be all zeros. So negative m plus 3 is equal to 0. So your m there must be equal to 3. Correct? Because if this is 3 here, the whole thing becomes 0. So m should be equal to 3, or just transfer the negative m to the other side class. It's 3 is equal to m, or m equals 3. And that's it. Where's m equals 3 there? The answer is letter D. Okay, this question class is questions 7 through 9. So it means that you will use this one from question 7 to number 9. Now, the question for number 8 is this. Let x1, x2, x3 be a solution to the above solution, satisfying x1 equals x2. You are going to find x3 there. By the way, you have to use your answer from number 7. So class, be careful with some questions here because if you got a mistake in number 7, then your number 8, probably you can get a mistake here also. Okay? So we have to use that for number 7. We have there the m is equal to 3 there, right? Then we substitute 3 there. We have 3 minus 2 here because this is m there. And then this is 3. Now we solve this. 3 minus 2 is just 1. 1x3. And you have this new one. This is the new system now. Okay? And that's it. Next, we have this property. X1 equals x2. So we can let that be equal to t there. Now, what to do? You have here three equations, right? If you replace x1 and x2 by t, how many variables are here in equation 1? You have two variables now. Then equation number 2, t here and t. So you only have two equations, you have two variables now. Now, do not use equation 3 anymore, class, because you can solve the value of the x3 there now because when you have two equations and two variables, you can solve it directly. Okay? So we have this. So no need for you to substitute it. This one, x1, x2 equals t to equation number 3 there. Now substitute that in your equation 1. This becomes t plus 2t, and this is 3t minus x3. Transfer x3 here to the other side and transfer 2 there. So 3t become minus 2 is equal to x. Okay, that is your first equation. This is equation A now. Now you substitute it now in your equation 2. Your t is your x1 and x2 there. So we have there 5t plus x3 is equal to 2. Now class, if this one is solving through substitution, but your calculator can do this already. You can type there 5t plus x3 is equal to 2. But there is no x3 there in your calculator, so you can use, for example, for the x3, you can use x there, and then your t, you can use y there. Okay? So combine this 5t plus x3 equals 2, and this equation here. X3 equals 3t minus 2. The calculators can automatically solve for x3 there. Okay, so here I use substitution. We have here 3t minus 2 as our x3, so we substitute it here. Okay, so this becomes 3t minus 2 now, and then we can solve the t there, which is equal to 1 half. Now substitute t in this equation, the equation A. We substitute it there, and then the result is negative 1 half. Again, in your calculator, you can type this and you can type this. So we have two equations there and two variables, x3 and t. Um, Again, when you solve that also, do not use x3 because there is no x3 there in your calculator, right? You can use x there, and then t, you can use y there. That's it. You can automatically solve for your x3 there, which is negative 1 half b. Okay, so no need for you to do something like this solving part here, this one, and then this one. So no need for you to do that. Again, using your calculator is enough to solve the value of the x3 there. Next, number 9. So you have this, again, the same question at the top. The number 9 we have here, let x is equal to x1, x2, x3 be a solution of the above system and a vector in R3 given that x is a linear combination of m. Your m is the vector set containing 1, 1, 0, and 1, 3, 2. Find x3. Okay, so which do you think is the value of x3? So we have this. Again, you can use m is equal to 3, we have to use that, and you have this system again. Okay, but no need for you to write this. It's in your paper already, right? In your scratch paper already because you solved 7 and 8 there. Now, what to do now? Your x is equal to, you have to multiply this with alpha, right? Alpha in your 1, 1, 0, and beta for 1, 3, 2. You have this. Your x is should be a linear combination of the two vectors there. You can use lambda 1 here and lambda 2. It's up to you. Any variable you want, or a or b here. Okay. Now we use alpha and beta. For Okay, this is actually equal because since your x is equal to x1, x2, x3, this is equal to x1, x2, x3. Now, combine all the first coordinates. So we have alpha plus beta is equal to x1. Alpha, the second coordinate, now we have alpha plus 3 beta is equal to x2. And then the last 0 for the alpha. So we have 2 beta is equivalent to the third coordinate, which is x3. So your x3 is equal to 2 beta. Now, the question says we find x3, right? Find x3. And your x3 here is just equal to 2 beta. So no need for you class to solve for the alpha. We need only the beta and then substitute it here and we have a value of x3 already. So we have this. First, you substitute that in equation 1. We only use equation 1 and equation 2 there because when you substitute this, x1 is alpha plus beta, x2 is alpha plus 3 beta, and x3 is equal to 2 beta there. What will happen is the equation becomes an equation with two variables now, the alpha and beta. And you only need two equations in two unknowns so that you can solve the alpha and beta. That is why we only need two equations. So we substitute it here in 1 and we substitute in 2. For 1, you can get 3 alpha plus 5 beta is equal to 2. For equation 2, if you substitute it there, again, we substitute these following values. And then for equation 2, we have 5 alpha plus 13 beta is equal to 2. Now, class, you can use your calculators again to solve this directly. You can use alpha there as x, and then your beta here, you replace that with y. So you have to solve the y there. Okay? And that's it. Just type that in a calculator, and your calculator will give you a value of your beta there or the y. After that, you multiply it with 2 because your x3 is multiplied with 2, right? It's 2 beta. And that's it. If you do that, you have a beta already, which is negative 2 over 7. So what I did here is I used by elimination. I multiply here with 5 at the top. So 15, it's here. Multiply A by 5, 15, 25, 10, and then multiply 3 here, the B. We have 15 also alpha plus 39 beta is equal to 6. Now they have the same 15 alpha here. We minus that one. 15a plus 25b, you minus the second equation, which is this, minus 15 alpha plus 39 beta, and then 10 minus 6 also at the other side. So this is 4. And then here, the alpha becomes now 0. And then 25 minus 39. We have negative 14. Divide negative 14 both sides, so 4 over negative 14, and reduce that to lowest term. You will get negative 2 over 7. Now negative 2 over 7, multiply that with 2 because your x is equal to 2 beta, and you have negative 4 over 7. Again, class, in your calculator, you can solve directly the value of beta. Just multiply it with 2 and you got the same value. And the answer is letter D, negative 4 over 7. And the time is 9:50. You can now take your 10-minute break, and we will continue after the break. already? Can you still hear me? And then can you still see the screen? Hello? Yes. Okay, so I will continue now. Okay, so we have this question number 10 and 11. For number 10, you are given here vector set with an M here. And then the vector set F with only just numbers are the two bases for your R3. So number 10, determine all values M element in the set of real numbers to make sure that E is a basis of R3. And you have their definition for the basis. It says that it should span R3 and it's linearly independent, right? So what to do there is um, definition of the span. Your determinant there should not be equal to 0. So arrange this 1, 2, 4 in the first column, 2, 5, negative 3 in the second column, and then negative 4, negative 3, m in the third column. Now use the first row to get the determinant. Matrix, you have 5, negative 3, negative 3m. The next, there's 2 here, so make it negative 2. Remaining numbers, when you remove the second column and the first row, you have here 2, negative 3, negative 4m. And then the last one, it should be plus, but this is negative here already, so it's minus 4. And then what will happen here is that you delete this and delete this first row and third column. You have there 2, 5, negative 4, negative 3. Now, class, for this one, class, this is minus 2 here, right? In the middle part, because you have to minus this. Now, if this number here is negative, so this one becomes plus, okay? Because this is negative 2, for example, and you make this minus, right? So minus negative, this one becomes plus. If this number here, if the 2 here is negative 2, okay? So we solve the determinant for this one, 5m minus negative 3 times negative 3, so positive 9. So we have minus 9 there. Minus 2, copy minus 2, and then this one 2m minus multiplying this, it's 12. And then minus 4. Okay, 2 times 3 here, it's negative 6. Minus negative 20, because you have there negative 4 times 5. So negative 6, it becomes plus 20 there. So negative 6 plus 20, the answer is 14. Correct? Now we solve this. Multiply 1 here, we have 5m minus 9. And multiplying this, you have negative 4m plus 24. And then this one is minus 56. And combine with the terms with m, and combine the terms without m. And that's it. We have there m minus 41. And since your determinant should not be equal to 0, um, determinant of a should not be 0. So this one is m minus 41 should not be equal to 0. Transfer the 41 to the other side. Your m should not be equal to 41. And that choice is here, letter C, for number 10. Okay, next. Now for number 11. Hmm. The m that it says there is, it should not be equal to 41. Now look at number 11 class. It says that we let m is equal to 0. Hmm. So if this is 0 here, your E is also a basis in your R3. Okay? Again, the basis class are not unique. So here, this is 0. So find the coordinate vector of the vector u with respect to the basis f. You have to get this. Given that the coordinate vector of u with respect to the basis e is this. Oh, you have given already your e is given already with equivalent to 1, 2, 3. So first step that we're going to get to class is the u first. What is the u? Because the question here, this is coordinate vector u with respect to the basis f, so we have to find the uf, right? So to get the u is given already 1, 2, 3. So this one are the elements of your lambda, right? This is the one here is the value of your lambda 1, 2, lambda 2, and then 3 here is your lambda 3. You have to multiply that in your E1, right? E1, E2, E3. Correct? The vectors here. And that's it. When you have this, we can solve the U now, the original U. So substitute it there, E1, E2, and then this one is E3. Okay, look at E3 class. This is now 0 because it says here M is equal to 0, so it should be negative 4, negative 3, 0. Here. Now substitute it there. So we have negative 7, and then 10, and then negative 10. So this is now your U. So how to get this? Okay, just multiply it class here. 1 times this, then 2 times this, and then 3 times this. Okay? Now get the first components. So first you have 1, 2 times 2 here, and then 3 times negative 4. So what is that? This is 4, this is 1, and then this is negative 12. 4, 1, and negative 12. 4, 1, and negative 12. So that's 5. So negative 7 if you add them. And that's it. It's there, negative 7. It's here. 1 times 1, 2 times 2, and then 3 times negative 4. The next um, second term. So for the second term, we have for the second term, we have um, 2 times 1 here, so 2, and then 2 times 5 plus 3 times negative 3. Okay, that's the second component. And you have this. Okay, we have 3 there. Now for the third component, just add them. So 1 times negative 4, 2 times negative 3, and then 3 times 0. So here, 3 times 0. And you have the negative 10. So we have negative 7, 3, negative 10. So this is now your original U. Okay, so again, our goal here is to find the UF, right? Now for the UF, what to do, we have to let U there, and then we have A times now our, to use the F there, right? This is your E1 prime, if you remember it. This is your E2 prime, and then this is your E3 prime. And you have the A, B, C. Your A, B, C there, class, is your lambdas in our previous slides there in the discussion. So this is your lambda 1, lambda 2, lambda 3. And the lambdas there, the values of your lambda, are your elements in your UF. Okay? Because here, as you can see, the value of the lambdas here is your UE. We have there 1, 2, 3. And that is our goal there. We find U first because this is equivalent to U. So 1 here and then 1 and 1 here in your C. It should be equal to your U. Your first component here is negative 7. That is why it's negative 7 here. A, B, C. Now next, there is no A, B, and we have C here. So 0 plus B plus C is equal to second uh, coordinate in your u, which is 3. So this is equal to 3. And the last one, we have 0 for the alpha a, then 0 for b, and we have 1 for c there. It's equal to the third component of u, which is negative 10. So this is very easy class to do. Your c there is automatically negative 10. Then when you substitute it here, negative 10, transfer negative 10 to the other side, it becomes plus 10 there. So your b now is 13. You substitute it here. B is 13 and your C is negative 10, and you can solve the value of your A there. So your C is negative 10. The final coordinate vector of UF is this negative 10, 13, 10. And where is that in the choices? Negative 10, 13, 10. And it's not there, right? So you have to pick none of the others. Okay? Next. 12 and 13. 12. Find all values of m such that this is to This is 3 by 2 matrix class. Um, Please do not imagine like there's a 0 here and there's a 0 here. No. The number here is negative m minus 6. This is m here and minus 6 is here at the top. Then 2, 2, 0. Again, there are no zeros here, okay, in this one. It's the first number here is negative m minus 6, partner with 0. Here, m and 2. Then we have here negative 6 and 2. So this is 3 by 2 matrix. Okay? Now, it says that you have there let V be element, be the vector set with element x. So those x only class is the element of your V. And x times a, it should be 0. And this is your a. Okay? Um, we have to find the value of m such that this one should be an element of the V there. So we have to multiply this with a, and the answer should be 0. So that if this one, if this is, for example, this is y, so y times a, if this is 0, then your y is an element here in your v. Okay? Just example, if this is just y, if we label it with matrix y here. Okay, so we do that now, we multiply it. So the first row, multiply it with a. First, we have negative 6 times, negative 6 2 times this. Okay? Multiply it to a, so negative 6 times, when you multiply it, it's row there times the column here, negative 6 to 2 times 3. So that's 6 and the negative 6. Oh, it's 0. It's here, negative 6 plus 6, it's 0. And then the last one, and the last one, negative 6, 2 times 2, 6 here. We have the negative 12 and then plus 12, and it's 0. So correct, it should be 0, right? So that it is element in your V. Now, m and 2, multiply it here in 1, 3. We have there m plus 6, correct? Then m2 times this, you have there 2m plus 12. So it's here. M2 times 2a is m plus 6 and 2m plus 12. Now you solve the m there. Again, it should be equal to the 0, 0 matrix. The 0 matrix. So this becomes 0 and this should be 0 here. So m plus 6 is equal to 0. We can solve m there is equal to negative 6. And then the second one, we have 2m minus 12. Transfer 12 to the other side and divide to both sides. Your m is negative 6 also. So class, as you can see, the answers here are now negative 6. So you can pick negative 6 directly. Actually, no need for you to solve the row 3 there. And yeah, because you are just wasting your time here. You solve it already here. Expected that the m there is also equivalent to negative 6. But you have to try. You have to try. Maybe there's another result here. So what if there's two results? Here we have um, the top always 0. You have the value of m here is negative 6. And we have here m is negative 6. So you have to pick their class here, letter A. M is equal to negative 6. Okay? That's the only thing that all of that will become 0. So that's it. So we only have one values for the m there, not too many. Now what happened if there is another m that you can solve here? For example, it's not m is equal to negative 6 here in the row 3. And it says there that wait, the question says that we have to find all values of m. So for example, if you solve here m is equal to 2, just an example, m is equal to 2, and here we have for row 2 we have m is equal to negative 6. So what do you think is the answer? Is it all of that? You have to choose between the numbers, or the answer must be none of them. The answer, class, is none of them. If you have their two results, then you cannot find the value of the m actually. Okay? Because um, this one here, if you multiply with a, it should be equal to 0. So it should be true to all m, right? And if you get two values of the m here, so it means that it will only satisfy the row 3 there. Okay, for example, if you have there m is equal to 2 and here m is equal to -6, there are different answers. So the 2 will only satisfy row 3. So the m is equal to -6 will satisfy only row 2. If you substitute -6 there in your row 3, it will not be 0 because you can solve their m is equal to 2 there. Just an example. Again, if you have two answers there, class, what will happen is you cannot find an m. You can say like none of the others here. Okay? And that's it. Again, if you find two values for the m. Next, we have this one. Find the dimension of v. Okay, for the dimension, I use this one. X times a is equal to 0, right? It's here. And we have to get the dimension of the v there. First, we let AB be the first row in your x times A. Multiplying that, it's 0, 0. And then multiplying that with AB is equal to this. 3 plus A plus 3B. Multiply this with this, A plus 3B. And then this AB times 2, 6. We have 2A plus 6B. Now you will say like, why is this 0, 0 here? Because it's here, class. Your x times A should be equal to 0. Now what to do? Your A plus 3B, you equate that to 0. And then your 2A plus 6B is also equal to 0 because they're at the top. That's the reason. They're all equal to 0. So what will happen? Okay, first look at the first equation and the second equation. The second equation is just 2 times the first. Okay? So this one is, if you multiply that with 2, the result is this one. So we only have one independent equation per row. One independent equation per row. And you have there 3 rows for your x because this is 3 by 2 matrix. 3 rows. So each row must satisfy one linear equation among its two variables. So each row has one degree of freedom. So you have 3 rows, multiply that with one free parameter each, so is equal to 3. So the dimension of your V there is equal to 3. Next, input-output matrix of the economic system with 3 sectors, industry, agriculture, service, is given below. So industry is here first row, right, and first column. Agriculture second row, second column, and then service is the third row, third column. Now m is equal to r. There's an m here, so there's a missing number. Then let b is equal to 20 times a. Given that the output values in the order industry, agriculture, service, of each sector. So class industry, the output is 60. Agriculture, the output is 40. Then the service, the output is 50. Question, find all the values of M element in the set of real numbers such that A is invertible. Okay, where can you say, class, that A is invertible? A is invertible if the determinant is not equal to 0. Again, you have a matrix, you have uh, your A is invertible if your determinant is not equal to 0. Okay. Oh, wait. Sorry. Um, it's wrong. The A class is invertible if your determinant is equal to 0. But there is one value m such that the determinant here will become 0. So we have to find it because it will make your A there not an invertible one. So that is why the choices here is this way. Okay? So your m has too many values such that your A becomes invertible. That's it. we have to find this determinant should not be equal to 0. So compute the determinant of A. First, we use row 1, 0 0.1, 0 0.1, 0 0.1. We pick that, and then this is the remaining matrix. The second 0 0.1, this is the remaining, and then the third 0 0.1, and then this is the remaining numbers in the matrix. Now we solve the determinant there, combining all the terms with m, and then the constants. We have this. So make this determinant should not be 0. So we have this one. Transfer this to the other side. It becomes positive. Now divide both sides by 0.005. That's equal to 75 over 500 or 3 over 20, the simplest form. So your m there must not be equal to 3 over 2. 20. Okay. So if your m there class is 3 over 20, then the determinant there becomes not 0 and it is not invertible anymore. Okay. Next. This is the question. What is the total value of products supplied by the industry to the agricultural sector in billions of USD? So this is industry to the agricultural sector. So your industry is here, row 1 and column 1. Agricultural sector is row 2, column 2, row 2. Now, where is this total value of products supplied? When you say supplied is this one, right? The zero point 0.1 here. That is your A12. Industry is row 1 and then the agriculture is column 2. So the coefficient in A is A12, which is zero point 0.1. Which is this number? A12. Okay, zero point 0.1. Now, the output is 40 billion. You multiply A1 to zero point 0.1 by 40 billion. The answer is 4 billion. So where is the 4 there? It's letter A for 15. Okay? So that's it. That is the total value products supplied by the industry to the agricultural sector. If it says industry to the service sector, so you have here row 1 and column 3. You multiply it with 0, 1. Then you will, if the question says um, total value of products supplied by the agricultural sector to the industry. So where is that? Agricultural sector. Find agricultural sector first in the row. It's row 2. And then the industry, if you switch this, industry is here row 1 at column 1. So this is your A21. We'll consider the A21 there, which is zero point 0.1. Again, it's agricultural to industry, and your industry class is 60. So you have to multiply that with 60. The answer is 6 there. If you interchange this industry and agricultural sector here. Okay? That's it. Next. Find the total input values billion USD of the industry sector, the total value that all sectors supply to the industry. So it says there the total value of all sectors supplied to the industry. And we have this one, column 1 of A, because that is for the industry sector, right? So we use these three numbers. And what to do, we multiply it with 20a, 20 times a, because your b there is equal to 20a, and the result is 223. So when you add this 223, the answer is 7. The industry sector output is 60. The 60 is here given. Okay. So next, the total input value should be 60 times 7 over 20. The real economy input output table is 20A, which is this one, the B here. Okay. So 60 times 7 over 20, if you multiply that, the answer is 21. And 21 is here letter E. Okay. Next question, number 17. You have here